Welcome to this tutorial on how to carry out watershed delineation using the hydrology tool in the toolbox. For this exercise, we'll be using ESRI's ArcMap 10.5, but the same process or steps can be replicated using ArcMap 10.2 and the later versions. So the steps that we'll follow is that we'll be setting up our work environment where we'll create a new project. We fill up the DEM, create a flow direction map or a flow direction raster, create a flow accumulation grid. We'll create a PowerPoint for the specific watershed that we want to delineate. Subsequently, we'll snap our PowerPoint to our flow accumulation and we'll delineate our watershed using that snapped PowerPoint. Then the preceding steps will be converting the raster to a shapefile and generating a gauge fraction which will be used as input to the variable infiltration capacity hydrological model. Welcome. So the first step is we have to create a new ArcMap document. So we'll start our ArcMap. So we'll create a new map document. So it's already a blank map, so we'll just save this. I had already created a new document, so I'll just name this as Watershed Delineation. My chosen work directory is under my documents, and I've named the directory Watershed Delineation. So I'm going to connect that folder using the connect folder tool. It's under documents. And the folder will be added here. I had already added mine, so there was no change. So the first step is to add a digital elevation model, a DEM. We can inspect the properties of the DEM. The resolution, the number of bands, and the size, and it's a 16-bit with no data values specified as this. So during the work process, there will be data set that will be generated as you do the DEM filling, the reconditioning. So we need to create a file geodatabase where all the data sets created during this exercise will be stored. So we select a new file geodatabase and you rename your file to your desired name. So I'll name this as Watershed Del To make it a default geodatabase so that all your files will be saved here, you right click and select the option make default geodatabase. To confirm this, or another way of making it setting your work environment, is to go to geoprocessing menu, environments, then under workspace you can set your desired directory here. For this case, I'm selecting the geodatabase that I've just created as my workspace for both the current and the Scratch workspace. My desired output resolution is 30 meters, so I will use the resolution of the DM. So I'll select same as layer, which is my DM, and this is the resolution of the DM. Then I'll select OK. So that concludes the first step of setting the work environment. So the next step will be to fill the DM. So this is to fill all the things that are in the DM, which will be important for the next steps in generating a watershed. So we have our input DM. We activate our toolbox. And just to make sure that the licenses are working and the extensions that are necessary for this analysis are working, just go to customize, then extensions, and ensure that Spatial Analysis tool or extension is checked. So to carry out DM filling, you go to Spatial Analyst under the Arc toolbox, then the Hydrology tool, and you double click on the Fill tool. In the Fill tool, you select your input surface raster as the DM that you want to fill, and in the output file, which will be saved in your default geodatabase, you can give it a name that is desired. For this, I will give it fill as the desired name. Then I'll click OK. So this tool will take some time depending on the speed of your computer. You can confirm that the tool is running by checking under the geoprocessing tool and results, the current session. You can see the fill tool is running. So do not worry if you do not see any pop-up messages. So when the tool runs, there will be a pop-up that the tool has run successfully, and your filled DM will be added to the map. So you can right click on the original DM and remove it, but just before that you can inspect the difference between the filled DM and the original DM. As you notice, the minimum values for this is minus 115, but for the filled DM is minus 18, and the maximum values or the highest point is at 4,987, while for the original DM is 4,177. So you can remove this original DM since it's not needed for the subsequent steps. And that concludes the second step of our exercise. So the third step will be to create a flow direction raster using the DM that has been filled as the input, and an output will be a flow direction grid. So similarly, we'll use the Arc toolbox under the Hydrology tool. You select the flow direction tool. The input surface raster will be the filled DM and an output file of flow direction. So I will specify my output as flow direction. Click OK and let the tool run. This tool similarly takes quite some time, so depending on the power of your processing or the power of your computer, this will take up to 5 minutes or longer. So the tool completes the pop-up message here, and you can inspect your output using the zoom in tool. So that completes the third step. So in order to do the watershed delineation, we need to identify where water flows, and this step is accomplished by creating a flow accumulation grid. So the next step will be using the same hydrology tool to create a flow accumulation grid or raster, and our input flow direction raster is the flow direction raster that we have already generated from the previous step, and I'll give it an appropriate name. And there are optional inputs such as weight raster, and the output in terms of the data that you want to get. You can have it as an integer or a float. So for this exercise, we'll just leave it as the default value, and they'll click OK. So similarly to the previous two steps, this process will take some time. The tool completes successfully. You can inspect the output or the results of the flow accumulation by zooming in. To improve the visibility or visualization of the results, you can change the symbology from the properties menu. You classify into two classes, and you define the intervals. So we'll pick 5,000, then we'll leave the other class as is. As you can see, it's a little bit easier